Well, hello everybody. Sorry that you have to watch this video right now. You're watching it either because you missed class or that I'm currently at a track meet. So here's the plans. If you have any questions on section 9-4, make sure that you get in and let me help you get those straightened out. What I need to do with you today is I need to cover section 9-5 with you. It's a fairly tough section, so hang in there with me. It's over solving logarithmic equations. So hang with me on that and we'll kind of go through it. My next couple of slides here are just if you had questions. So of course let me just get through those real quick. Before I start, what you'll need in front of you, your day 3 class examples, but I need to review something that's going to show up today, and I know it's been a while since you've done that. I need to review factoring with you. I'm going to review 4 kinds of factoring that'll show up throughout our lesson today. So instead of surprising you with them as we go, I thought I'd review them with you real fast. If you would, look at x squared minus 3x minus 18 equals 0. I would like to factor that, aka unfoil that. Well, what I'm going to do is I'm going to go to parentheses, and I'm just going to do whatever it takes to unfoil this or factor it. What does that mean for you? I need something times something that's going to give me x squared. Well, in this case, that's going to be x times x. I need you to go find me 2 numbers that multiply to be negative 18. Your choices are 1 and 18. One's positive and one's negative. 2 and 9. One's positive and one's negative. 3 and 6. One's positive and one's negative. Find the ones that you can make add up to be negative 3. Well, they're going to be right there. I'm going to need a positive 3 and a negative 6. So if I come up here and go negative 6 and positive 3, now to get my 2 answers, one answer is going to be positive 6, the number I get when I set that equal to 0. The other answer is going to be negative 3, the number I get when I set that equal to 0. Remember, guys, when you factor, you could quickly FOIL this back out and make sure you're right. X times x is x squared. That would give me plus 3x minus 6x is negative 3x minus 18. So that's going to be one of the types of factoring that shows up today. Another type that shows up today is called a difference of squares. This is a simple difference of squares. I could make it a little tougher on my next one. But remember, guys, on a difference of squares, and let me just do that right now while I'm talking about it. Let's go 4x squared minus 25. This one's way too easy. Difference of squares means you know the square root of the first term and the square root of the last term, and they're separated by a negative sign. Well, the key thing here, your middle terms are going to drop out. The thing that makes the middle terms drop out is this magical plus and a minus. Now you just take the square roots of both. So there's going to be a 2x there, a 2x there, a 5 there, and a 5 there. Now when you go set this equal to 0, this answer, you're going to add 5, divide by 2. This answer, you would subtract 5, divide by 2. So that's a difference of squares. You might also see what's called a common factor. In this case, I'm going to look at 15x squared minus 10x. The golden rule of factoring says take out whatever they have in common. So I'm going to factor out a 5 and an x, which leaves me a 3x minus 2. When I set each of these terms equal to 0, 5 times something is 0. So one answer is 0. This answer, I would add 2, divide by 3. There's my other answer. So that's going to be my common factor. Now the one that's going to work you a little bit, there's 2 ways. I will show you the way or review with you the way that you learned in Algebra 2. It's one of those that the a value is not 1. Kind of gives us a hassle. It's not a difference of squares. There's nothing in common. Remember, this was your process last year. You went 3 times 10 and got 30. You now go find 2 numbers that multiply to be 30 that you can add up to be negative 17. So my choices are 1 and 30, Also negative 1 and negative 30, because two negatives also make a positive. I could go 2 and 15, negative 2 and negative 15. I could go, and I'm going to stop there, because there's the two numbers that I need. Negative 2 and negative 15. Now here's your next step. You guys wrote this as 3x squared. Use whichever one of these you want to use first. I'm going to go negative 15x minus 2x plus 10 equals 0. So all I've done, guys, is I've expanded this negative 17x. Now we group these two terms together, take out a 3x, which leaves a x minus 5. Out of these two terms, I'm going to factor out a negative 2, whatever this sign is, which leaves me also an x minus 5. If you've done a good job, this and this will be the same. If you haven't, you've messed up somewhere. Now to bring it home, I'm going to factor out that x minus 5 binomial, which leaves me 3x minus 2. Now when you go get your two answers, that's positive 5. That is positive 2/3. Those are going to show up throughout the lesson on a couple of these. So I wanted to get them out of the way now a little bit so they won't surprise you in the lesson. Also today, guys, as we go, there's 3 different types of solving equations. I'm going to group them together. So if you would, go put a triangle on your number 1, your number 4, put a triangle around that, like so. You can tell my PowerPoint's a little off. Also around the next two I have here, also around number 6 and number 10 and number 11. Here's why I had you do these. All of these problems need solved by using the logarithm or the natural logarithm, but they don't contain a logarithm. So the first little group that I'm going to do here contains no logarithm. They will before we get through with them, but as of right now they don't. So I need to show you how we'll solve these, and we'll go easy to tough. So I'm going to jump around on your sheet a little bit, and then I'm going to have some that I call a circle problem. That means they're going to have a log on each side. Then I'm going to have a star problem, just logarithmic on one side. Those are our 3 main types that show up today. So all of our answers are going to be exact, so you won't need your calculator today. So here goes. 7 raised to some power equal 12. We talked about this one last class. I'm going to introduce and take the log of each side. So remember, this becomes the log of 7x equal the log of 12. Remember, our rules of exponent says that exponent can come down. So this is really x log 7 equal log 12. Right now it doesn't really matter, but I'm working in a base 10. Now to get x by itself, I'm going to divide both sides by log of 7. So there's one way you might see your answer. Log of 12 divided by log of 7. Or it could also be written like this. Log base 7 of 12. This is probably the cleaner answer. On my answer key, I just showed you both of them. So there's the first one I'd like to do. If you will, drop down to number 4 if you would. The reason I put that in that group, it didn't have any logarithms on there. This is a tough little problem here. So hang with me. I decided to get the second toughest one out of the way. 2 and 3 don't have a common base. If they did, that would be the easy way. But here's what I'm going to do. I'm going to log both sides and bring down that exponent. So it looks like this. 3x plus 1 in parentheses times a log of 2 equal 4 minus x in parentheses times the log of 3. Now to solve this, I need to distribute, because what I need to do is I need to get my x's on one side, my non-x's on the other side. So I'm going to distribute, and it's going to give me 3x log of 2 plus log of 2. So I just distributed. I'm going to do the same thing over here. This becomes 4 log of 3 minus x log of 3. Now here's your goal. Get your x terms on the same side, your non-x terms on the same side. So I'm going to move this term over there. I'm going to move this term over here. So here's what I've got now. I've got 3x log of 2 plus x log of 3 equal 4 log of 3 minus log of 2. And then what I'd like to do is this. Let's factor out an x out of each of these. So I'm going to take out an x, which leaves me 3 log of 2 plus log of 3 equal, leave this side alone, 4 log 3 minus log of 2. Now to bring it home, divide both sides by this quantity to free up the x. So here's my final answer. 4 log 3 minus log of 2 over 3 log 2 plus log 3. So a tough little problem for problem number 2. Number 1 was pretty darn easy. Number 4 jumped up quite a bit. But that's going to be our steps. Like I said, if they don't contain a log or a natural log in there, I was going to get those out of the way first. That way I'm not jumping around on the sheet a lot. If you will, come over to number 6. When you look at number 6, notice that there's an E in there. Whenever there's an E in there, we're going to wind up using somewhere, sometime, the natural log. The reason I'm going to do that, I know the natural log of E is 1. So what I need to do first on number 6, I need to divide both sides by 2 first. So I've got E to the 5x plus 2 is going to equal 4. Now I'm going to natural log each side. So I really have this. But I'm going to skip a step on you. I know that this is going to come down front. And I know the natural log of E is 1. So here's what I really have now. 5x plus 2 equal the natural log of 4. To get x by itself, I'm going to call this the natural log of 4 minus 2. You cannot call that the natural log of 2. Got to leave them split up. All over 5. So there's my exact value of that. So E shows up, natural log is going to be used. Here's another number 10, another one of those. Now I'm going to show you a shortcut on this one. That way it doesn't have to be solved like this guy here. I spy on number 10, I spy that 3 and 9 can be rewritten as a common base. I'm going to leave 3 to the negative x alone. But I'm going to think of 9 as 3 squared. So I really have 3 squared times 1 minus 2x. Now that you've got your bases the same, you can ignore those and just concentrate on your exponents. So I'm going to have the opposite of x equal, I'm going to distribute that 2 minus 4x. I'm going to add 4x over here and get 3x to be 2. So x is 2/3. I could have done it like I did the second one that I just did, but it just takes longer. If you spy a common base, this is about as fast as we can get. If you struggled on number 4, I've got another one coming up just like it. Here's number 11. Once again, there's no logarithm involved, so we're going to have to introduce the log. 2 and 5 don't have a common base. So here's what it's going to look like. I know I'm going to take the log of each side and bring down that exponent. So I'm going to have 2x plus 3 times the log of 5 equal the quantity 3x plus 1 times the log of 2. Now remember, you got to get your x's together, your non-x's together. So I'm going to distribute again. So I've got 2x log of 5 plus 3 log of 5 equal 3x log of 2 plus log of 2. I'm going to move my x term over here. I'm going to move my non-x term over there. So it looks like this. 2x log of 5 minus 3x log of 2 equal log of 2 minus 3 log of 5. I'm going to factor out an x on the left-hand side, which leaves me 2 log of 5 minus 3 log of 2 equal what we had over here. Finally, the ending answer, x is going to be log of 2 minus 3 log of 5 over 2 log of 5 minus 3 log of 2. There's your answer. There's other ways to write it, but this is going to be as easy as you can. While I'm here, I'm going to say a couple of things real fast. No, you can't do that. That's going to be your answer, guys. No, you cannot do this. You can't cancel off those log of 5s and those log of 2s. You can't do anything like that. There's no like terms in there, so that is going to be your answer right there. Okay. Moving on a little bit. The next little section I'd like to talk to you about, if you would, go through and circle so you know which ones are alike. Circle number 2. Circle number 5. Here's why we're circling these. Notice on number 2, there's a log on both sides. On number 5, there's a natural log on both sides. Don't scribble them out. I was just pointing them out. The next two I'd like for you to circle, circle number 8 and number 12, because once again, there's natural logs in every term, or there's logs in every term. And that's all of my circle problems. So let me backtrack. What are my circles going to represent? The circles means that there's a log or a natural log on both sides of the equal sign. Usually when this happens, guys, this is when factoring could show up. That's why I did that to you. So look at your number 2. This is going to take us back to what we did last class. Look at the right-hand side real fast. Only look at this. I'm going to write that as a single logarithm. So it's going to look like this. I'm going to have log base 3 of x plus 6 divided by x plus 2. Remember last class that divided by means plus, it means division, so I'm going to divide, equal log base 3 of x. I'm going to pause at this moment because you've done some good things already. Notice that here's log base 3 and here's log base 3. All I need to do now is set this argument equal to this argument. I can ignore the log base 3. So here's where I'm going to go next. Let me switch back. I'm going to say, well, if I can make x plus 6 over x plus 2 equal to x over 1, life is good. So notice I just set this argument equal to this argument. Now I'm going to cross multiply. So I'm going to have x squared plus 2x equal x plus 6. I went here to here, there to there. The reason I went here to here first, guys, because I knew the x squared would show up, and I like the x squared on the left. I need to set this equal to 0. So I've got x squared plus x minus 6 equal 0. So I had to set it equal to 0. Now here comes that f word. We got to factor this. So I'm going to go two parentheses, x and an x. I need you to find me two numbers that multiply to be negative 6. So your choices are 1 and 6, 2 and 3, that you can make add up to be positive 1. And those numbers are positive 3 and negative 2. I'm going to set each of those equal to 0. And I'm going to get answers of negative 3 and positive 2. Okay. But now here comes a little loophole. You cannot take the log or the natural log of a negative number. So if I plug negative 3 right here, you're going to try to take the log of a negative number. Your calculator is going to give you an error if you want to try. Also, if I plug negative 3 here, I'm going to get a negative number. This is called an extraneous solution. It means we did all the work and we found it. It's just not going to work for us, though. So we got to throw that away. My only answer then, x is going to be 2. So watch out for extraneous solutions. Usually when you have an equation, just make sure that when you sub it in, a negative doesn't show up. Here's my number 5. It's going to behave the same way as number 2 did. Notice that there's a natural log on both sides of the equal sign. So here goes. I'm going to think of this as the natural log of x over x minus 3 equal the natural log of 2. Well, don't worry about these natural logs, because if you can make this argument equal to this argument, we've got it. So I'm going to go x over x minus 3 equal 2 over 1. I'm going to cross multiply. So I've got 2x minus 6 equal x. I'm going to subtract x over here and get x. I'm going to add 6 over there to get 6. To decide if it's extraneous, look back up here. I can take the natural log of 6. That's okay. I can take the natural log of 6 minus 3, which is 3. So that's going to be okay. So that is my answer. So a little bit of factoring, a little bit of cross multiplying. My next two circle ones was your number 8, because once again, notice that there's a natural log on both sides of the equal sign. Natural log on both sides of the equal sign. So once again, I'm going to think of this as the natural log of 4x minus 2. So no change there. Equal the natural log of 4 over x minus 2. Well, these are going to be equivalent if I can make 4x minus 2 equal to 4 over x minus 2. Now this is a tougher little problem. To solve this, I'm going to have to cross multiply. So I'm going to have 4x minus 2 times x minus 2 equal 4. Let me tell you what you don't get to do. You don't get to set 4x minus 2 equal to 4 and x minus 2 equal to 4. Because if they both equaled 4, you'd have 4 times 4 is 16. So, way wrong. I'm going to have to FOIL this out. So I've got 4x squared minus 8x minus 2x plus 4 equal 4. We need to set that equal to 0 now. So let's go 4x squared minus 10x. Subtract 4 over and you're going to get 0. Now to solve this, I'm going to factor out a 2x because that's what they got in common. So I'm going to take out a 2x, which leaves a 2x minus 5 equals 0. Set that piece equal to 0, and I'm going to get 0. Set this piece equal to 0, and I'm going to get add 5 divided by 2. Before I move on, make sure that you could use them. Go back in and plug in 0 and see if a negative number is going to show up. Well, if I plug in 0 right there, 4 times 0 is 0, 0 minus 2, you cannot find the value of the natural log of 2. So 0 doesn't work. My only answer is 5/2. And then here's my number 12. Might be my last circle one if I remember right. And then we go to stars. So once again, a log on each side. So here goes. I'm going to think of this as log base 2 of x plus 5 equal log base 2 of 3 squared. So I move that squared up. So this really becomes x plus 5 equal 9. Subtract 5 and get 4. I looked up here and made sure I could use a 4 because 4 plus 5 is 9. I can take the log of 9. So keep hanging on. I know we're about that 27-minute mark. I've got one more type to show you. The next group I went with stars. If you would, put a star by the rest of them. That would be number 3. That would be number 7. That would be number 9. That would be number 13 and 14. Here's what I did on my next little section. Notice that one side has a log, or a natural log, the other side doesn't. That changes my game just a little bit. Number 3 is probably the toughest one on the worksheet. So let's do an easier one first. Let's jump on number 7. And then I'll come back and get number 3. Like I said, it's the toughest one on the class. Well, number 7, I'm going to do just like what we did. I'm going to try to combine this into a single log. Once I do that, I'm going to have log base 5 of x plus 2 times x minus 2, because that's what that plus sign means, equal 1. Now before, I just had to make that argument look like, oops, I don't have a log over here to do that to. So here's my next step. I'm going to write this as an exponential equation. So I'm going to think of this as 5 to the first equal x. Base, exponent, answer. So I'm going to say 5 to the first equal x plus 2 and x minus 2. I will FOIL out this side, which leaves me an x squared minus 2x plus 2x minus 4 equal 5. Two ways to solve this now. I'm going to subtract 5 to the other side and get x squared minus 9. Here's a difference of squares, so I'm going to factor that into x minus 3 and x plus 3. So my two x values look like 3 and negative 3. But once again, look, make sure there's not an extraneous root. I can plug in a 3. 3 plus 2 is 5. That's okay. 3 minus 2 is 5. I mean 1. That's okay. Let me plug in negative 3, though. That's really what I was thinking, negative 5. Negative 3 minus 2 is negative 5. I can't use the negative 3. So there's my lone answer. Okay, let's get the toughest one on the whole worksheet out of the way. I got log of 3x minus 4 plus log of 2x minus 5 equal 1. Well, here's what it's going to look like. When I combine these to a common logarithm, I'm going to have log of 3x minus 4 times 2x minus 5 equal 1. Well, this really becomes now, there's a base of 10 hiding right there. So 10 to the first equal 3x minus 4 times 2x minus 5. If there's a shortcut from this point, I would give it to you guys, but there's not. I'm going to FOIL this out and get 6x squared minus 15x minus 8x plus 20, and that's set equal to 10. I need to set it equal to 0, so here goes 6x squared minus 23x plus, move the 10 over and get a 10 equal 0. So there's where we are for a second. Now we have to factor this one. So here goes. There's no shortcut to this one. To factor this, the a value is not 1. So I got to do this. 6 times 10 is 60. I need to go find two numbers that multiply to be 60 that you can make add up to be negative 23. So my choices, 1 and 60, 2 and 30, 3 and 20, 4 times 15. Well, I'm going to stop. I spy I could use 3 and 20 to get negative 23. So let's go ahead and rewrite this as 6x squared, whichever one you want to put next, minus 3x minus 20x plus 10. Why did I put them in that order, guys? I noticed the 3 and the 6 go together. The 10 and the 20 go together. Makes it a little easier for me to factor here in a second. So out of the first two, I'm going to take out a 3x, which leaves a 2x minus 1. Out of negative 20x plus 10, I'm going to take out a negative 10, which leaves a 2x minus 1. That's good news. These are the same. So I now have, I'm going to come up here, I have 2x minus 1 times 3x minus 10. So looking at this, my 2x values are going to be 1/2 and positive 10/3. I need to check for any extraneous solutions. Well, if I plug in 1/2 up here, 3 times 1/2 is 1.5. Minus 4 is negative. Right away I know I can't use that. The 10/3 works in both of them, so my only answer, x equal 10/3. Looks like we got a couple more coming your way, so hang on there for just a couple of more minutes. I think number 9 is a little bit easier because the factoring's easier. So here goes. I'm going to write this as log base 10 of x times x minus 21 equal 2. Let's write it as an exponential now. 10 squared equal x times x minus 21. Let's distribute and get x squared minus 21x. And let's move this 10 squared over as negative 100. Now we need to factor x and an x. You need to find two numbers that multiply to be 100 that you can make add up to be 21. Well, I know that there's 4 quarters in a dollar, and I can make those add up to be negative 21 by going negative 25, positive 4. Go get your two answers. Here's 25, negative 4. You probably already know this one's coming. You're not allowed to use the negative 4. So my lone answer is 25. Believe it or not, 13 and 14 are a lot easier. So if you think you're golden, you can stop the video and get working. Otherwise, it's going to take me about a minute to do each of them. So might peek at your number 13. I got 3 natural log of 5x plus 7 equal 13. I need to isolate the natural log of 5x. So I'm going to subtract 7 first. So I'm at 3 natural log of 5x equals 6. Then I'm going to divide both sides by 3. So I've got the natural log of 5x equal 2. Now remember, guys, the base here is at e. So now this becomes e squared equal 5x. Well, x must be e squared over 5. So there's the exact value of that. And the last one, don't cheer. When I go to solve this one, it's going to look like this. I'm going to bring down that 3x minus 1. So I've got 3x minus 1 times log base 2 of 2 equal 20. The key here is you recognize something before you work real hard. Log base 2 of 2 is 1. So I now have 3x minus 1 is 20. Add 1, divide by 3. Get my answer of 7. So guys, there's section 9-5, a tough little section. So get together with the partner as soon as everybody gets through with the video there. Good luck on working those assignments. Once again, if you need help, come in. Good luck.